Okay, so we're going to work on the composition of functions. That's 2.3, and this is the lesson. It's part 1. So the composition of functions is a case where you have one output becoming the input for the next problem. And this is something that we use all the time. We don't necessarily think about it. If you think about your paycheck, for example. So your paycheck, oops, helps if I have my pen working. So you get your paycheck, and at the end of the year, somebody tallies that all up to give you a W-2 or a 1099. And then from there, you're going to plug that into your 1040 form, and then you find out whether you need to pay taxes, owed, or refunded. Okay, so this is a case where, as you can see, there's multiple steps here, and you need each of these pieces of information to get to the next. Similar problem would be having number of items sold and your sales function to get your sales revenue, right? There's my, there we go. So my sales function, and then I find out, so I figure out how many I've sold, and then I have to take care of cost of sales. And then from the cost of sales, between the sales function and the cost of sales, then you have the profit, right? Because you are leaving. You find out what's left after you've got your sales revenue, and you subtract the cost of the sales. So, like I say, we use this all the time. We don't necessarily think of it in terms like this when we make it abstract like math, but we do use it all the time. Alright, so here I'm going to we have a couple of examples. I'm going to go ahead and work through these, and hopefully they will help us feel comfortable with doing our composition of functions. So keep in mind that I'm going to put it into, I'm going to put a variable, or I'm going to put something into like an x into the first function, which is going to give me the output that then becomes the input into the next function. Alright, so, and then you're going to have some other answer, and it can go on and on. So anyway, I wanted to get started on this. My f of g of x, if you take a look, I start with the x value and I work my way out. So in this case, we're told that we have an x of 5, and we need to start with our g of 5. So I'm going to do this like as a chain, right? I'm going to do my first link, and then I'm going to use that information to give me my next link. So I have a 5 minus 7, that's my g of 5. So that's going to give me a negative 2. So my f of negative 2, not sure why this is not working real well, but my f of negative 2 is going to be 2 times negative 2 plus 3. And in this case, I'm going to have a negative 4 plus 3 is going to give me a negative 1. Alright, so as you can see, this became my output here for the g of x, right? The g of 5 became the result that went into the f of negative 2. Right? So that's kind of how that worked. So in our next case, I'm going to go ahead and take a look. Let's go with this. Alright, so here I'm going to have my negative 6, and I'm going to start with my f function. So I have 2. Instead of an x, I'm going to put in my negative 6 plus 3. Alright, and this is my f of negative 6. That's going to give me a negative 12 plus 3 is going to give me a negative 9. And then my g of negative 9, right? So this is my output here, becomes my new input. And then I have negative 9, negative 7 is going to give me a negative 16. Alright, now just because I have an f and a g doesn't mean I have to use that same value. I mean, I can do an f of a g, or f of g of x, I can do a g of f of x. I can also have an f of x. And people will be like, well, when are we ever going to use that? Well, if you think about compound interest, that happens all the time. Every time you have a credit card, a loan, a mortgage, if you have a savings account and you're accruing interest, all of those are instances where you have compounding interest. So what your initial deposit is, then you either gain or owe interest, and then that becomes the new balance and it starts over again. So it just becomes this cycle of interest. Alright, so let me go ahead here, and I've got my f of 7. Well, I'm going to have my f of 7 is going to equal 2 times 7 plus 3. So it's going to give me 14 plus 3 is going to give me 17. So my f of 17, right, is going to give me 2 times 17 plus 3. So I'm going to have 34 plus 3 is going to give me 37. So this would be my ending answer. If you want to think about it like this, you can sometimes use, okay, so this is our first iteration. You can use a subscript or an index subscript indicating which one it is. So your first one would start here and then your next one out. Alright. So we're going to use, and here we've been using just this whole f of x, or f of g of x, or g of f of x, or whatever we're using there. Now I'm going to talk about f composed with g of x. Alright, and this is, we're going to use slightly different numbers now. And I want to go ahead and I'm going to, again, I'm going to start with my smallest, or the innermost first. So I'm going to have my g of x. So my g of x is going to be, actually let me go ahead and erase that. I'm going to use that as my, so I'm going to have a 12x plus 4. And then I'm going to plug that in, this is my new x, into this formula. So I'm going to have a 4 times the 12x plus 4 squared. And at this point, I'm going to go ahead and do the multiplication. I won't necessarily do the multiplication in all of them going forward, but for the time being I want to do at least one or two of them. So here I'm going to have my 12x plus 4, 12x, and then my 4. So I have my 12x times 12x is going to give me 144x squared, and then this is going to give me a 48x, and this is also going to give me a 48x, and then I'm going to have a 16. Alright, and then I'm going to multiply that whole thing by 4. So I'm going to have 4 times 144x squared plus 96x plus 16. Alright, and then we would just go ahead and multiply that out. The other thing you could do would be factor out all the 4's. Alright, so you would wind up, you would have 4, and then you'd have, that would be multiplying a 4 times 3x plus 1, and then that's going to multiply a 4 times a 3x plus 1. So you could also, so you could have it be 4 to the 3rd power. You could take it 16, that would be a 64. So you could wind up going a couple of different ways about this, but this ultimately would become a either this, or you could take this and do the same thing. Again, you just kind of work it all the way through. On this one, I'm going to have with my f is going to be my input. I'm going to use a different color just so it's easier to see which one's which. So my f is going to be my 4x squared, and then I'm going to plug that into my g, which is a 12x plus 4. Alright, so this is going to give me 48x squared plus 4. Now, if I wanted to, I could factor a 4 out, but in this case I would say leave it as it is. We wanted to just kind of get it to this point. Here I'm going to actually plug in a value. Alright, so it's not quite so abstract. These have been pretty abstract at this point. So here I'm going to plug in for my g of 5, I'm going to have 12 times 5 plus 4. So that's going to give me a 64. And then that 64, I'm going to put that into the f, right? So my f of 64 is going to become 4 times 64 squared. Alright, and if you wanted to, we can throw that into the calculator and come up with 64 squared and then multiply that by 4. Since we're talking fairly large numbers, I'm going to just leave it for the moment. So my 4x squared is going to be my innermost, right? My f of x, or f of negative 6 is going to become my 4 times negative 6 squared. So that's my f of negative 6. So I'm going to have 4 times 36. Alright, so my f of negative 6 becomes 144. My g of 144 equals 12 times 144 plus 4. Alright. So if I wanted to actually like work that one out, I could do 144 oops, I got a little carried away from me. I'm going to go there, there, right, and here I'm going to have my 12. So that's going to be 0, 4, 0, 4, 0, 1, and then 0, 2. It's going to be 0, 8, and 0, 8. So, with that in mind, I'm going to wind up with, where's my point here? Okay, so there's my 8. And then I'm going to have a 12, so that's going to be a 2 plus the 1. So that's going to become a 7, and then a 1. So if I did this right, I should have a 1,728 plus the 4, which would give me 1,732. And again, that's if I did my math right. If you have questions on this, there is going to be another video, but I want to make certain that we get this up and done.